All right, let's jump right in. Today, we're taking a look at the very near future. And I'm not talking about some far-off science fiction fantasy. We're talking about the huge technological shifts that are already happening and are pretty much set to redefine our world by 2026. So let's get into it.
So I want you to really think about this for a second. For years, we've seen tech as a tool that just waits for us, right? You type a search, you get an answer. You run a program, you get some kind of output. But what if that whole relationship is about to completely flip on its head? This massive change actually has a name. Experts are calling it the Agentic Era. And the big idea here is simple, but it is profound. Our technology is changing from a passive tool into an active, autonomous teammate. It's not just about asking for stuff anymore. It's about giving AI a goal and letting it figure out the how.
Okay, to really wrap our heads around this, we're going to look at it like a giant construction project. First, we're going to explore the essential foundation that has to be built. Then we'll see how the intelligence gets layered right on top. And finally, we'll look at the absolutely crucial shields we need to protect this whole powerful new system. So let's start at the very bottom, the foundation. See, before you can have these super smart systems doing all this complex work, you need a completely new digital infrastructure. The way we've been building things, it's just not going to cut it anymore. The very first building block is a total revolution in how software itself gets made. Forget that old stereotype of a coder hunched over a keyboard typing endless lines of code. We're walking into the era of AI-native development. In this world, a human just states their goal, the what, and an AI agent actually writes, tests, and deploys the code, the how.
And the change here? It's just dramatic. Traditionally, you had humans writing code, systems running on general-purpose CPUs, and security was kind of like a big wall around a castle. But in this new AI-native stack, the development is AI-generated. The horsepower comes from super-specialized chips, like GPUs, built just for AI. And security? It's not just a wall anymore. It's baked right into the hardware itself. It's a whole new blueprint.
Okay, so if AI is building all the software, what's actually running the AI? Well, that brings us to our second building block, the power plant. Training these gigantic AI models takes an unbelievable amount of power. We're not talking about your everyday servers here. We're talking about custom-built AI supercomputers designed for one thing and one thing only: massive, massive processing.
Now for the final part of our foundation, security. And this is a big one. We've gotten really good at protecting our data in two states. We encrypt it when it's just sitting on a hard drive, that's data at rest, and we encrypt it when it's zipping across the internet, that's data in transit. But there's this third, critical state that we often forget about. So here's the problem. The second a computer actually needs to use your data to process it, it has to decrypt it in its memory. And in that one moment, poof, it's exposed. It's vulnerable. This data in use gap has been a huge security headache for a long, long time. The solution, and our final piece of the foundation, is a technology called confidential computing. Just think of it like a super secure locked box, an enclave, that lives right inside the computer's chip. The data goes in, gets processed, and comes back out, all while staying completely encrypted and totally invisible, even to the owner of the computer. This is what builds the trust we need for everything that comes next. Okay, our foundation is poured. It's set. Now we get to the fun part, building upwards and adding the intelligence. This is where we go from just infrastructure to actual action, giving our new system both brains and brawn. So this intelligence layer isn't some single, giant, all-knowing AI. Nope. The future is in what's called multi-agent systems. Imagine you have a complex goal, like plan a product launch. A manager agent breaks it down, then hands off tasks to a researcher agent, a writer agent, and a designer agent. They all work together, they critique each other's work, and then they deliver the final project. This could totally change how we all tackle complex work, from class projects all the way to professional creative work. But for these agents to actually be useful, they need the right kind of brain, right? A general-purpose AI is kind of like a really smart intern. It's impressive, but you probably wouldn't trust it to perform brain surgery. And that's exactly why we're seeing the rise of domain-specific AI models. These are the senior experts trained on super deep specialized data for fields like medicine or law or engineering, making sure you get precision where it really, really matters. So far, all this intelligence has been purely digital, just thinking inside a computer. Well, physical AI is where that all changes. This is the moment the AI gets a body.
By putting these advanced models into robots and drones and other machinery, we're moving AI from just thinking about a problem to physically doing something about it out in the real world. This is how the digital starts to literally reshape the physical. So we've built a powerful foundation, and we've layered on some incredible intelligence. But a world this powerful, this autonomous, it needs rules. It absolutely needs protections. It needs shields. This final layer is all about setting up the rules of engagement in a brand new world. First off, the very idea of a single, global, borderless internet, that's kind of falling apart. There's a trend called geopatriation taking over, and it's being driven by new national laws about data privacy. Data isn't a free-flowing global thing anymore. Now it's being treated like a national asset, and it's being forced to come home and stay within a country's digital borders. This next shield tackles a problem I'm sure you're already very familiar with. As AI gets better and better at making super realistic images and videos and text, we're facing a real crisis of trust. I mean, how do we know if what we're looking at is real or just a really sophisticated AI-generated fake? The answer is a technology called digital provenance. Honestly, the easiest way to think about it is like a digital birth certificate for content. Using new standards, a special cryptographic signature gets attached to a file the moment it's created. This lets you see exactly where an image or video came from, and, this is the crucial part, if it has been altered by AI. It's a tool for helping us trust what we see again. And finally, our whole approach to cybersecurity has to change. The old method of just building a digital wall and waiting for someone to attack it is way too slow. The new game is preemptive cybersecurity. This is a shift to active defense, to deception, basically setting digital traps. Security teams create fake files or fake logins called honey tokens. The second an attacker touches one, alarm bells go off, and you know you've got an intruder.
Okay, so we have our 3 layers: the foundation, the intelligence, and the shields. But here's the most important part. These aren't just separate trends. They are all deeply connected. They form one single functioning system. Let's see how that works.
Let's make this super clear with an example, like a fully autonomous factory. The physical AI robots building things on the assembly line, that's the intelligence. They're running on a private on-site AI supercomputer, that's the foundation. And the shields? Every single line of code they run is verified by digital provenance, and all the factory's data is kept inside the country's borders because of geopatriation. You see? Every layer is essential for the whole thing to work. We have covered a ton of ground, from the hardware all the way up to geopolitics. So what does all this actually mean for you, for your future career, and for the world that you're going to be building? Well, the big picture is this. The era of just being a passive user of some one-size-fits-all global tech platform is coming to an end. The future is about becoming an active builder, an architect of these secure, autonomous, and increasingly localized systems. This whole shift is being called sovereign autonomy. But this brings us to one last and honestly one huge question. We've just laid out the blueprint for a world run by unbelievably powerful AI agents, supercomputers, and robots. But did you know that training a single large AI model can use a staggering amount of electricity? So, have we really figured out how to power this incredible new future sustainably? That's a thought I'm going to leave you with. Thanks for joining me for this explainer.